Okay, the question says, after substantial heating, 0.194 grams of uranium produced 0.233 grams of a compound with oxygen. The empirical formula is, to be able to calculate and figure out the empirical formula, we need to start by figuring out how much oxygen we have. And we can figure that out by subtracting the amount of uranium, 0.194 grams, by our whole compound, which was 0.233, and we get 0.039 grams of oxygen. Okay, so we're going to use this to determine the number of moles of each atom. To do that, you have to look at the periodic table and look at the atomic mass of your element, and then use this conversion fraction here, which says 1 mole of uranium is 238 grams. So in essence, we're going to divide the number of grams of uranium that we have, 0.194, we would divide that by 238, and that gives us 0.000815 moles. We're going to do the same thing for oxygen, where we can see we have an atomic mass of 16, and we have 0.039 grams of oxygen. So we're going to divide that by 16, and it will give us 0.00244 moles of oxygen. So now we can determine our mole ratio for each of these elements by dividing the amount of moles that we have by the smallest amount of moles that we found. So in the case of our uranium, of course, if we divide it by itself, we will get 1. And for our oxygen, we had 0.00244 moles. If we divide that by the smallest amount that we found, 0.000815, we get 3. So we can use those ratios to get our empirical formula, which would be UO3, uranium oxide. And uranium oxide has been used in some formulations for enamels and for porcelain.